In this video, we're going to express as a defined integral the volume of a solid that is formed by rotating a region that is defined like this. I'm going to read them in a way. This region, when we rotate it about some line that is not the x-axis nor the y-axis. So, for example, we have the region, let's say R is the region enclosed by the graph y equals square root of x and the line y equals 1. Find or express the volume of this solid as a defined integral when the solid is generated by rotating the region R about the line y equals 1. And here we have the graph, and you need to, well, if you can graph them, do it. And next you need to find the region that is R, so just put it in black, and then express the volume. So I'm going to read all the problems in case you want to stop the video and try to do it. The other is R is the region enclosed by y equals 3, x equals pi over 2, and y equals 3 cosine of x. We will rotate this about y equals 3. This is the graph. And you need to, find the region first. And R is the region enclosed by the lines y equals 1, the y-axis, the curve y equals cube x, and the solid will be generated by rotating R about the line y equals 1. This is the graph. The other is the region enclosed by the lines x equals 3, y equals 2, and the curve y equals 1 over x minus 1. We will rotate it about x equals 3. The region enclosed by I equals 2, y equals 2, y equals 2 times x minus 1 square, we will rotate it about y equals 2, the graph. The R is the region enclosed by y equals 1, x equals 4, y equals square root of x plus 1, about y equals 1. It will be the rotation. Next, the region R is enclosed by y equals square root of x plus 2, x equals minus 2, y equals 1, y equals 3, and the solid will be generated by rotating R about x equals minus 2. This will be the graph. Next, the region R is enclosed by x equals 4, y equals e to the x, y equals 1. We will rotate it about the line x equals minus 4. This is the graph. Next, the R is the region enclosed by y equals 1, y equals minus 1, x equals 2, y equals x square x minus 1. The solid will be generated by rotating about y equals minus 1. The graph. And the last one is the region R is enclosed by the region that is, by the line x equals pi over 2 and sine of x, but the region is to the left of the line x equals pi over 2. So here you have, and the solid will be generated by rotating it around x equals pi over 2. So here we have the graph, and you need to fill with black what would be the region rotated, and like that you will know how to find the volume. Alright, so let's begin. So in the first one, here we have I equals square root of x, the line y equals 1. Our region is this. This is our region. So we will rotate this around the line y equals 1, and we will generate a solid. Now we will use the disk method. So if we are rotating it around y equals 1, we have disks that are like this, in which, in order to find the volume of one of these disks, the width will be delta x of each one. Now the area is the area of a circle, that is pi square r. Now what is r? We need to find the radius. The radius would be, because we will have another of these, like here when we do the rotation. This would be, you can see it as that we have the radius being this. Sorry, actually these are the disks, like this. All these are the disks, because we are taking this solid and cutting it in cross sections. So all of these will be the circle, delta x is the width, and the radius would be, as you can see, would be the distance from I equals 1 and square root of x. So the radius r is equal to square root of x minus 1. The area will be pi times this square, so x root of x minus 1 square, and the volume will be of just one disk will be the area, that is pi times the square root of x minus 1 all of this square times delta x, that's the width of each disk. If we want to sum the volume of each disk, we will put the defined integral. Let me leave the limits of integration at the end of pi, I can put out the pi here, times the square root of x minus 1 all of this square times delta x. Now the limits of integration, we are coming from, well, here we say the region enclosed by y equals a root of x and y equals 1. So here you see the left endpoint is when y equals the square root of x is equal to 1. So we have 1 equals to the square root of x. So x is plus or minus 1. This plus or minus 1 is because we're in the right quadrant here, we are talking about plus 1x. So this will be our limit, our first limit of integration. We are going from y equals 1 to actually we can put it as from x equals minus 1 to because if x is equal to x is equal to 1, x would be equal to 1, so we just need to put x equals 1. So we will go from 1 to here I don't put another point, but we could take it as, I don't know, let's say from this to, I don't know, to 4, to x equals 4, whatever. So this. Alright, let's continue with the other one. Here we have the region enclosed by the line y equals 3, x equals pi over 2, and y equals 3 cosine x. So is this region. So we will do again disk methods. We will rotate this around y equals 3. So our disks will be our first. We will have this same region, like if you can imagine that we rotate it around y equals 3, you would see something like this. So our disks are something like this. Again, the radius will be the distance from y equals 3 and the function, that is 3 cosine x, because if we subtract the f of x, in which f is 3 cosine x, that is, first we have y equals 3, that is this value, here this value, for example, this is 3, and if from that we subtract y equals 3 cosine x, we subtract all this, we will have only this. So for that, here the radius is r is equal to 3 minus 3 cosine x. So the area would be pi r squared, so it would be this square times pi. The volume of each disk will be this times delta x. If we want the volume of all the disks, will be the defined integral from when does the line y equals 3 intersects with the 3 cosine x. This will be in let me put it 3 is equal to 3 cosine x. So when cosine x equals 1, so this would be in 0. So we go from 0, from 0 to here y equals 3. From 0, from 0 to pi over 2, this is pi over 2. From 0 to pi over 2 of 3 minus 3 cosine x squared dx. So this would be the expression of the volume, or you can put the pi out. Remember that if our discs are perpendicular, the discs are perpendicular to the line in which we are rotating, and the delta could be delta x or delta y. In a while we're going to see delta y. In this we will come to delta y. And so delta x, and so you need to put the boundaries, from some x to another x. So the boundaries are with respect to x, and here you have respect to x, where you are integrating with respect to x, and the function needs to be in terms of x. Let's do one more of this with x. The region between y equals 1, y equals 1, y equals cube x, and the y-axis. So is this region. We will rotate it about y equals 1. So if you can imagine, you will have another region like this. This will be our solid. If you do cross sections in order to see the discs, you will have something like this. So here the radius is, you can think it as the difference between y equals 1, so this distance is 1, and the distance of y equals x cubed, because x cubed is, for example, x cubed is this. So if you subtract 1 from 1 to this, you would have the region. So the height of that would be the radius. So here the radius would be r. R is equal to 1 minus cube x. Pi r squared would be pi times 1 minus x cubed all square.